Hello, I want to go over some CUDA code that I've been doing, and it involves doing some ray tracing. So ray tracing some spheres into, like an environment. Um, so yeah, I've been practicing this. I'm still not 100% perfect at it, but I'll try my best to explain it and explain to y'all like what's happening. Um, so you're gonna need at least some knowledge of like some matrices and like vectors and stuff. Um, and functions because this is low-key kind of hard. I'm still struggling on it. But yeah, let's get started. So these are the functions that you're going to need for now. So we're going to define a struct called, not my struct, but float um, 3x. So what this is we're going to create a float 3x with three floating numbers, which is going to represent our um, XYZ coordinates um, for any point really. So here we're gonna define float x, y, and z. Um, so yeah, and then we're gonna make a function that will um, initialize a float object like automatically without us having to do, you know, like array dot x is equal to 1 or like array dot y is equal to 2. Just an example, right? So we can just say like um, float 3x. I'm gonna just say vector, sorry, not array. Float 3x is equal to, I'm gonna just give you the name of it. Make f3, and then we just pass in 1, 2, and 3. So then it automatically, um, within vector, it's already gonna have um, its x, y, z's initialized to this. So here we're going to define the function. We're going to first do this device. So what this says is telling the compiler that the host and the device can both use this function. Um, um, Host meaning the CPU and device meaning the GPU. So between the two, they can communicate with each other. Um, and they both know what this function is. I'm going to call it make f3. Then we're going to pass in a float x, float y, float z values, right? And then I forgot to give it a value. It's going to be of float 3x, so we're going to return an xyz value. So here we're just going to say return x, y, z. Pretty simple. Pretty simple for that. Next is we want to do an operator overload, which will allow us to do um, matrix addition and subtraction. So we're going to use the same um, definitions of host and device inline, and then we want it to be of type float 3x again. And we're just going to call this operator plus. This is telling it that if we encounter, if we encounter two values of float 3x, vector 1 and vector 2, if we say vector 1 plus vector 2, it's not going to do the regular addition where it's just like one integer value or one floating value at a time. It's going to automatically know that we're going to be wanting to use this function in here, and it's going to do, vector 1 dot x plus vector 2 dot x, which gives us, vector 3 dot x, right? Gives us a new value. So here we're going to pass in two float 3x objects, A and B, float 3x. We want to reference it, A and then B. And then here we're just going to return make our make function up here, make f3. And here we're just going to say a dot x plus b dot x, and then a dot y plus b dot y, and then finally a dot z plus b dot z. And that's it. So we're going to return the sum of each x, y, and z values between the a and the b vectors, and then just make a new x, y, and z. And then we're going to do the same for subtraction, but instead we're going to do that. And then instead of adding, we're subtracting right here. Now we want to do a scalar function because this we're going to need it, right? In this code. So we're going to do, uh-oh, so let me delete this. Same thing here, same definition, multiplication this time. But instead of another vector b, we're going to call it int scalar. Oh, okay, sorry, float scalar because it can be a floating number as well. Float scalar. So here, what we're going to do is we would want to return the scalar is being multiplied to each x, y, and z value of the um, initial vector that we put in, initial float 3x object that we put in. So we're going to want to return call the make f3 function. And then here we're just going to pass in a dot x times the scalar, a dot y times the scalar, and then a dot z times the scalar, right? So this essentially just if we have, you know, 1, 2, 3, and then our scalar is what, 10. What it would do is it would multiply each x, y, and z values, and then it would just create a new float 3x vector, and the new values that would be returned is 10, 20, 30, right? Um, Now, just in case we put it in backwards, so scalar first and float 3x after, the compiler won't know. Um, it's going to be a mismatch because you can't multiply a float by a float 3x natively. Um, so we're just going to call this function again, and then we're just going to swap the values here. Swap the values here. So this is just in case we put the scalar in front first, and then the vector after. And then after this, since the compiler already knows we've already defined the operator of multiplication, vector times the scalar, we can just return a times scalar. Because then it would call this function here, and then it would automatically do it. So this is just in case we swap the values, um, right? So now after this, I'm gonna finish up with the dot product, and then I'll go over other functions later. So after this, we're going to do the host again, device, uh-oh, device, inline, and then float dot product, float dot product. Now dot product is we're multiplying the if both vectors are the same size, we're just multiplying the x, y, z values of both vectors together. So here we're just going to pass in two floating vectors here that we created, a and b. And then here we're just going to do return, again, make 3f, or f3, sorry. And then here what we're going to do is just do a dot x times b dot x, Um, sorry, this is going to be, we don't need this, sorry. Dot product, I'm tripping. Dot product is we're going to take the x, y, and z values of both vectors and then just sum it all together. So we're just going to return um, sum of a dot x times b dot x plus b dot y. So we don't need to make um, 3f for this because we're just returning a just a number. So this is if, let's say, again, 1, 2, 3 is our first vector. 4, 5, 6 is our second vector. It would do 1 times 4 plus 2 times 5 um, plus 3 times 6. And this would equal what? 4 plus 10 plus 18, which would give us 28, 29, 30, 31, 32, right? 32. So this would return 32 if this is what we inputted. Um, so I'm gonna end it there just for these functions, and then I'm gonna do our magnitude length, a normalizer function, cross product, and a clamp after. Yeah, so just wanted to go over the functions real quick before I moved on to the functions that we created before I moved on to the other stuff. So, like I said, we had a struct float 3f or 3x, I should say 3x, and then here we had a float x, float y, float z values, right? So if we created like an object, you know, vector 1, float, float 3x vector 1. Within vector 1, we would have a dot x, dot y, dot z values, right? We could access them by saying dot x, y, and z, right? So we could say vector 1 dot x is equal to 1, vector 1 dot y is equal to 10, vector 1 dot z is equal to 3.3, whatever, because it's float, right? It could be this 5, 6, 0, 7, 8, like that, whatever, right? But this is tedious and it takes too much time, so we made the function make3f, which is of type float 3x. So float 3x make 3f, or f3, sorry, f3. And then here we're just going to pass in the x, y, z values. So x, y, z, and these are all floats. And then here what we were going to do is we're going to return the x, y, z values, because that's what float, that's what the return type of this is. So x, y, z. So we just return that, right? So instead of doing all this, we can just say vector 1 is equal to call the function make f3, and then just pass in the values, 1.00, 10.560783.3, right? And it would already, this would be the x, y, z values, right? It would already do it automatically. And then our next function was, again, of type float, and this is just the operator overload, so float, so the compiler knows that we're adding, if we call in two float3x values, we're adding those values in together. So it was operator plus, like this. And then here we're just going to pass two constants. I'm going to just label it above const 3x a, and we're going to reference them. That's an and, that's a reference sign. A 3x reference b. We want to reference them because we don't want to we don't want to change their value. We just want to grab whatever whatever the value is that is stored at the XYZ of A and B. We don't need to change it. We just want to look at what they are, which is why we reference them. And then here we're going to call make 3f function, so the function from above, make f3. And then here what we're going to do is just add the xyz values like I said before. So a dot x plus b dot x, a dot y plus b dot y, a dot z plus b dot z. And then that would return a new sum. So if we say new vector is equal to, let's say a is, here, let me do this. A is equal to make f3 1 1 1. So all the values, x, y, z values for a are 1. A is equal to make f3 2 3 4. The new vector, if we do, this is supposed to be b, not a, b. So if we do a times b, we know that these two are of float, float 3x values, right? So the operator is going to call this function, or sorry, what am I doing? This is supposed to be addition, sorry, not multiplication. Addition, like this. So compiler already knows that, oh, okay, we're going to be doing addition of float 3x, and it has a addition operator to it. We're going to check, oh, can we do regular, like the addition, like x plus y is equal to z or whatever. No, we're going to be using this operator instead, which then returns u vector is then equal to what? 1 plus 2, 3, 3 plus 1, 4, 4 plus 1, 5. So new vectors is now this value, right? And then same with subtraction. Copy, paste. Same with subtraction, but this time it's backwards. We're not adding, it's subtracting. But we're passing in the same values. Minus, minus, minus. So then if we were use subtraction instead, new vector is equal to a minus b. New vector would then be what? A minus 2, or sorry, 1 minus 2, so it'd be minus 1, comma 1 minus 3 minus 2, comma minus 3. Boy, I hope that's right. Yeah, so new vector would be this, right? And then our multiplication operator now was FLOAT 3x operator, and that's an asterisk sign. So here again we're passing in, instead of this is our scalar, right? It's not actually multiplying it's not actually doing matrix multiplication is what I'm trying to say. It's just scaling it. So FLOAT 3x, again, reference. Oh my God, that's a horrible reference sign. How can I do reference sign? I think it's like this. No, it's not, but you get the gist. A, and then float, scalar, so here is if we do a vector, a float 3x vector of 1, 2, 3 times 5, the compiler is going to know that, oh, we're doing this multiplication right here, this like scalar multiplication. So here what we just want to do is return make F3, just return an F3 of the vector times the XYZ, the XYZ values in the vector times whatever the scalar is. So here we do a times a dot x times scalar, a dot y times scalar, a dot z times scalar. So then let's say new vector again. New vector is equal to, this is a, oh sorry, this is a, and then this is scalar, a times scalar. We would know that, oh, it's not doing just regular multiplication because we know this is of type float 3x. So we would call this function right here, and then it would do new vector is equal to 5, 10, 15, because this is what we return. And then we create another one again just in case we do it backwards. Copy. So in case we put the scalar up front and then the actual vector behind it, the compiler won't know what that is. So here we just swap these two values right here. So this is float scalar, and then FLOA 3x reference A, right? So, and then instead of, since we already know what the dot operator is, what the multiplication operator is, we don't even need to call in a make3f, because then it would look up here. We would say, oh, okay, so we're doing multiplication again, so we just come up here and then call this right here. So we would just return the vector A times scalar, right? Because we already know, okay, we have this multiplication defined. Okay, we already know that this is float 3 of type float 3x. So we just come up here and say, oh, okay, we have a float 3x right here. We just pass in into this right here. This is what we're doing, just in case we do it backwards. And And then we had, did I do dot product? I don't know if I did. Yes, I did. And then finally we have our float dot product dot product. Whatever. You already know what I'm trying to say. Float dot product, which takes in two float 3x values. float 3x. I can't do this sign, so I'm just gonna say ref as for reference. Reference A float 3x reference B. And then here, what we're just going to do is, just since it's a float, it's going to give us a floating point number, or it can give us a floating point number. It can be an integer as well. So we're just going to return the sum, the multiplication sum of each x, y, z value. So a dot x plus b dot, not plus, times b dot x plus a dot y times, I forgot the plus, a times y times b times y plus a times z times b dot z. And then, so say if we had, 1, 2, 3 for a, and then 4, 5, 6 for b, it would do 1 times 4 plus 2 times 5 plus 3 times 6, which then gives us the value of 4 plus 10 plus 18, which then gives us 32. Right? 28, 29, 30, 31, 32. Yeah, 32. So yeah, those are just a quick rundown of what these functions are doing and how we have them defined. So yeah, like I said, I'll be going over magnitude, normalize, cross product, and clamp after.